Alright, so this is my first attempt to do homework using a touchpad, a little pen tablet, and Microsoft Paint. So, brace yourselves for an exciting ride. So on the most recent web assignment, first problem had a train. It was moving at constant speed, and we were given some distance or some times. It moved in certain directions, and then we had to find average velocity. So for constant speed, we got it moving, basically I think everyone had it moving due east, so like that, for a time, sometime t1. So we're going to say we're going to call that like 1. And then second, it was moving at some angle theta that was measured east of due north. So if I could draw that there, then we're talking about this angle here was specified, and it moved like that for a time t2. The angle given was east of due north, so it was going clockwise from north instead of what we're usually used to, which is counterclockwise from east. I think that probably tripped some people up because they didn't read it carefully and they thought it was north of east instead of east of north. And then for the third bit, it moved west for some time t3. All right, so let's figure out how far it goes for each one. That's pretty easy. So the distance is just velocity times, or sorry, distance is speed times time. It's going in a straight line, same direction all the time, constant speed. So the distance it goes to the first one is just v times t1, pretty easy. Distance it goes to the second leg is, of course, v times t2, and distance for the third leg is v times t3. Well done, Mr. Smith. So let's move on and now convert these into vector displacements. So what I want to find is the displacement, or the displacement. Yeah, the displacement it does for the first leg. So I'm going to call that R1, and that's going to equal this D1, and it's going to the east, which is to the right. So that's in our positive x direction. Let's set up the usual, vertical y positive and then horizontal x positive to the right. So R1 is going to be v times t1, and what is it again multiplied by? I hat, of course, which is our straight to the right vector. And let me do the third one because that's also easy. This one is going exactly the opposite way, so that's going to be negative v t3 I hat. And then the third one is where it gets tricky, of course, because we've got this this vertical and horizontal components. So I'm going to do the horizontal here in red, showing off colors here. And so you can see sort of that if I that's like that distance there for that triangle. And then the vertical I'm going to do in blue. So what we can see is then that we use sines and cosines to break this down into a horizontal component times I and a vertical component times j. So R2 is going to equal, this distance is t2, and then to find the horizontal bit we multiply it by sine of theta because it's because it's being measured from the vertical there. So v times t2 sine theta times I hat, and then the other part is v times t2 cosine theta times j hat, and that's the vertical bit, that's the blue bit. So this here, let me just see if I can use my colors. This bit here is the red vector, and then this bit here is the blue vector over here. So that's just the component you can the decomposition to components. All right, so now we can just put this together and get the whole distance it travels. So I'm going to say R is R1 plus R2 plus R3. So just to put a little picture on this, this is R1 here, right? This was going straight to the east. And then for the second leg of the trip, it was going, at some angle theta there. And this vector is R2. And then the third one is coming back this way, R3, going back to the west. So we can just add all these up arithmetically, and we get R equals equals, and so just to make this clear, I'm going to draw, you know, the R, total R vector in brown there. But see, this vector here then is R. Okay, so to make all this clear, there's our R equals R1 plus R2 plus R3. So I'm just going to put these all together and say VT1 I hat plus VT2 sine theta I hat, and then minus VT3 I hat. So I'm putting all the I hat term, all the horizontal components together, and then the last thing is this vertical component here, the only J hat bit. So VT2 cosine theta times J hat, and I'll just close that off. So finally, at long last, what we can put together is we can gather all the I hat and J hat terms. So R hat equals VT1 plus VT2 cosine, oh, I'm sorry. Let me see if I can undo that. Yes, I can. VT2 sine theta minus VT3 I hat plus, I'm going to just do another bracket for the fun of it, VT2 cosine theta J hat. So this is our expression for R, and when we substitute in our values for V and T1, T2, T3, and theta, we should get the correct answer. So for my values, let's see, my values were V equals 63 kilometers per hour, T1 equals 43 minutes, which is, and I'm going to use the fancy little Windows calculator, so 43 divided by 60 equals 0.71 hours, 0.717 hours. T2 equals 18 minutes, which equals, I happen to know this, 0.3 hours. And then T3 equals 55 minutes, which then equals, that's going to be 11, well, 55 divided by 60, it's going to be 11 divided by 12, which is 0.917 hours. Okay, equals 0.917 hours. All right, so let me pause while I do all this in my calculator, because there's no sense in making use of it. I'm sorry, and then I also should mention that theta for me was 52 degrees. So let me plug all this into my calculator and see what comes out. Okay, I'm back having done all this, and I believe that my final displacement vector is going to be 2.06 I hat plus 11.64 J hat kilometers. Here's hoping, you know, because I don't know that for sure. So let me scroll a little. And so what I'm saying then is that my final displacement vector is going to look like this for 2.06 kilometers, and then there's going to be a vertical component like that, which is going to be 11.64 kilometers. And so then I need to find, let's see, what do we want? They want the average velocity of the train during this run. So first let's find the total time. So T is T1 plus T2 plus T3, and if I just go over here and look at the times I had, that's going to equal, let's see, 0.917 plus, whoops, 0.717 plus 0.3 equals 1.934 hours. 1.934 hours, and then what they want me to do, what they want is the velocity and or the magnitude and direction of the velocity. So let me calculate the magnitude of my R vector, which is 2.06 squared. Oh, hang on. Yep, 2.06 squared plus 11.64 squared, and those total up to that, to 139.7, and then if we take the square root of that, no, I wanted to invert that. Dang it. Oh, I see. What the hell? So let's try, so what was it? It was 139.7. So 139.7, and I'm going to x to the y that to the 0.5. And so the magnitude is going to be 11.82 kilometers, which then means our velocity is going to be the magnitude of the direction, or the magnitude of the velocity, which is what they want first. So what they really want is, you know, average speed, or not average speed. No, magnitude of the average velocity is going to be this distance divided by this time. So let me just divide that by 1.934 hours, and I'll get 6.11 kilometers per hour. And the angle should equal then, and they want, now the angle they ask for in the answer is counterclockwise from east, so they go back to standard angle conventions here, and so the angle here is going to be arctan of, come on, oh, what's going on here? Okay, arctan of 11.64, which is our y displacement, over 2.06, which is our x, and let's see, what is that? 11.64 divided by 2.06 equals that, and then we want to do inverse tangent of that, and it looks like we get 80.0 degrees. Alright, so 80.0 degrees. So this, I believe, is my answer, and I'm 6.11 kilometers per hour at 80 degrees, and I'm going to try it now and find out. 0.11 and 80, and let's roll the dice here, and yes, I got it right. So there you go. Probably the biggest problems people had were either unit conversions or missing the fact that this angle for number 2 was specified as east of north instead of north of east.